easiest way to answer, you will just have to say, okay, I'm at 4.1.1, right? So the easiest way now, you are just going to substitute, let's say, two or three numbers, right? So I'm gonna say y is equals to 1 over 3 to the power of 1. Y is equals to 1 over 3. You don't even have to write it down. Y is equals to 1 over 3 to the power of 3. So that's just going to be 1 over, okay, no. That's going to be 1 over 3, right? And then here I'll have 1 over 9. And then here I'll have 1 over 27. So my x values are increasing because I'm going from 1, right? And then I'm going to 2 and 3, so they're increasing. But then for my y values, I start at 1 over 3, and then I go to 1 over 9, which is less than 1 over 3. And then I go to 1 over 27, which is less again. So my y values are decreasing. Therefore, what's our answer?
It's a decreasing function.
It's a decreasing function. Exactly that. So you can just do that. Yeah? Since we do not have a graph that was given to us, that's now the easiest thing to do, to just see that, to be able to answer that question. So we have a decreasing function. Okay, then at 4.1.2, they say now determine p to the negative 1, the inverse of p in the form y, right? So they want my inverse now. Already we know. We are going to swap everything. Né? So I'm going to have x is equals to 1 over 3 to the power of y. Therefore, now y will be a log with my base of 1 over 3 to the power of y. Can we all, what's this? Can we all go from an exponential function to a logarithmic function without making mistakes? Okay, I made a mistake. I just saw it now. I made a mistake without making mistakes like me. So I'm just trying to find out, are we all comfortable with this? Ne?
Yeah. No. Yes, sir.
1.3. They say now write down the domain of the inverse now, p to the negative 1. That's my inverse. So already, as we have discussed yesterday, né, when for my p, now my original graph, let's say now my range for my original graph, né, for p of x, when I go to now my inverse, my range now becomes the domain of the inverse because we are swapping everything, right? So as soon as, and you can also see the mark allocation is just one mark. So as soon as they ask you this now, what you are going to do, you're gonna refer back to your P and find the range of your P, right? You're just going to find the range of your P. After finding that range of your P, you're just going to write it in terms of X for your domain, because range is the Y values, then the domain is the X values. That's the easiest thing that you're going to do, right? So maybe to just give you guys a visual representation now, already I know that my y-intercept is going to be 0 and 1, né? And then here I have my horizontal asymptote, and then what else do I have? My value for b is 1 over 3, so it's a decreasing function, so it's going to be something now like this. So let's see, it's I will have what's this? So that's my y-intercept, and then here's my thing. So if I substitute 1 over 3, which will be somewhere here, then I'm gonna get 1 over 3. So my graph will look something like this, right?
Yeah.
Something like that. Sure. So now let's see my y values. Ne? My y values, where do they exist? Because this is my graph of p of x. Where do my y values exist? They exist above my x-axis, right?
Yeah.
They exist above my x-axis. So basically, from positive infinity until y, until 0, but then they cannot be equals to 0, right? Because of my asymptote here, that y is equals to 0. So I'm just going to say now, this is in terms of my domain, y will be now an element of, I can write it like this. Let's see. I can just say y must be greater than 0, right? I can just say that y must be greater than 0, but not equals to 0. And then y is an element of a real number. So basically, that's my p of x. Né? Then for my inverse, that's my range, right? That's the range of my p of x. Then for my inverse, this will now become my domain. It will be y must be x
Greater than 0.
greater than 0. X must be an element of a real number. Just that. X must be an element of a real number equation of the asymptote. So okay, I have an asymptote now, but then of p of x minus 5. So 4.1.4 will be p of x minus 5 will basically be p of x minus 5 will just be 1 over 3 to the power of x minus 5, right? And remember what I told you about the original way or the standard form of our exponential function, right? The q now is my asymptote, right? So since now I have the value for q here, my asymptote will just be y is equals to negative 5. That's easy as that, because my f of x is equals to 4 over x minus 1 plus 2. I have a hyperbola now. So everything I know about my hyperbola, I must start referring to it. So 4.2.1, let's see. Write down the equations of the asymptotes. Yeah, it's usually the first thing they're going to ask you, right? So the equation of my asymptotes will just be x is equals to 1, and then y is equals to 2. You're done. Then a 4.2.2, because usually they ask you these and then they will ask you to sketch. Né? So 4.2.2, they want you to find the x-intercept. So we know x-intercept, we just make our y 0. And then after more, let's see. That's going to be 4 over. And they say sketch the graph of f, label all asymptotes and indicate the intercept with the axis. So okay, you're just gonna sketch the graph quickly. Let me just do this thing quickly. Okay, good to go. So firstly, we're just going to sketch our asymptotes, right? So we had our asymptotes being x is equals to 1 and then y is equals to 2. So here's my x is equals to 1. Here's my y is equals to 2. And my x-intercept is 1 and 0. Okay, no, that's not possible. But it's still in my third quadrant, so it shows we are okay. Then we have minus 1 and 0 here. Then my other graph will be here, right? So sure. Okay, 4.2.4, what do they say? Use your graph to determine the values of x, for which 4 over x minus 1 is greater than or less, greater than or equals to negative 2, right? So with a question like this, already you are seeing this is familiar to my f of x, right? Because my f of x is 4 over x minus 1 plus 2. So to just kind of, so we can deal with our graph, né? We are going to say now, again, we are given 4 over x minus 1 is greater than or equals to negative 2. So we are just going to take 2 this side. And then we are going to have 4 over x minus 1 plus 2 is greater than or equals to 0. So now basically we are looking for the values of x now, whereby my f of x is greater than or equals to 0. Ne? Are we clear with that?
Yeah.
Sure. So after now, let's look at the graph because we have to use the graph. Ne? So let's see. Where is now my graph positive? Let's start there. Ne? And I think even yesterday we had a question like this. But where is my graph positive? Ne? Already positive, you know that I must be above my x-axis. So from now, my x-intercept right until my asymptote. Now, let me just write it down. This is y is equals to 2, and then x is equals to 1, up until my asymptote, right? So that's where it's positive. And then also from this side, after my vertical asymptote, going there. So I'm just going to have a, what's this? I'm just going to put it like now. My value for x must be greater than 1. Ne? So greater than 1, I'm talking to this vertical asymptote. So for any value that is greater than 1, my graph is positive, right? As we can see here. Ne? Or now, so yeah, let me just 4.2.5. They say determine the equation of the axis of symmetry, right? We have an axis of symmetry now of f of x minus 2. So already this is a shift, man. This is not our original f, it's a shift that has a negative gradient. So my m is negative. Let's see. So 4.2.5 f of x minus 2. So what does this shift tell us? First of all, basically, when we are saying, when we have a number inside a bracket and then it's a negative, that means we are shifting now to the right. Yeah? So any shift that is in the bracket is either, it's a horizontal shift, basically. So if it's negative now, that means we are moving 2 units to the right. Yeah? That's where my graph is moving. Okay. And then what else are they saying? So I'm just going to start by finding that graph. Né? So it's just basically my f of x, which is 4 over x minus 1 plus 2. Then 2 units to the right. What is it now? In my graph, what is that? 2 units to the right Okay, let's say I'm here by 0. I'm at 0. Ne? To move to 2, to move to positive 2, am I gonna add or subtract if I'm moving to the right?
Subtract or add or add.
Adding. Right? So now in my graph, I'm gonna add 2. Ne? I'm gonna add 2. But then the thing is that within this part, it's gonna be a minus, but then as soon as it goes to my equation, it's gonna be a plus 2 because I'm moving 2 units to the right, basically. Is that making sense? That kind of that confuses a lot of people, né? It can get you. So this will be now my f of x minus 2. Then it will just be my 4 over x minus 1 plus 4. Yeah? So now they want the axis of symmetry for this graph that has a negative gradient. For this graph now, we are no longer looking at this. So my axis of symmetry for this graph will just be now, since I'm looking for an axis of symmetry with a negative gradient, I will just have y is equal to minus x plus c. Yeah? And then to find my gradient, I'm just going to substitute the point of intersection of my asymptotes. Ne? So I know that I have an asymptote at 1 and also at 4. So I have 4 is equal to minus 1 plus c. And then my c will be 5. So therefore y will be minus x plus 5. Here's that. Are we good?
Yeah.
So say if banyaka the positive gradient, then formula E over y equals to positive x plus c.
Yes, you're gonna just put
Okay.
x plus c, then still you're gonna substitute your point of intersection of your asymptotes. It's exactly the same thing. Now
Part 2 will be discussed in the next video. For now, subscribe and go practice mathematics. You are writing paper 1 on the 3rd of November in case you forgot. Are you still here? I'm gonna have to tell your teacher that you're busy lazying around. Follow me on Instagram at Sebas Tutoring Academy, then go and practice mathematics.